this question is on the topic of electrolysis. In fact, it's a very popular question. It will be good for you to be able to understand what is actually going on rather than just memorizing how to get to the answer. Alright, so what is happening over here is that they tell you that the same amount of charge, alright, was used to deposit titanium and copper in an electrolytic cell. So for that to happen, one way is to connect the two cells in series, as what I've shown in the diagram. Okay, so when you connect two electrolytic cells in series, you will have the same amount of current passing through the two cells, and you will have the same amount of charge passing through the two cells. Okay, before I go on to describe what is actually happening in the cell, it's very important for you to know that when we say the same amount of charge, it actually means that you have the same number of moles of electrons passing through the two cells. Alright, we will see later that this is a very important concept for us to be able to solve the question. Now, when the current is passed into the electrolytic cells, ions are going to be discharged at the respective electrodes. Alright, for metals to be deposited in an electrolytic cell, it means that the metal ion is being reduced at the cathode, right, at the cathode, so over here. Okay, and since the question already tells you that titanium is being deposited and copper is being deposited, what it means is that your copper ions is going to be reduced at the cathode of cell number 2, the one on the right, to give you copper metal. Alright, if you look at the half equation, the reason why you need 2 electrons is because copper has a charge of 2 plus. Okay, how about for titanium then? Titanium, we have no idea what is the charge, and that is what we are supposed to find in the question, so we let it be X plus. Okay, for an ion of plus charge, you will require 1 electron to be reduced to the metal. For an ion of 2 plus charge, you will require 2 electrons to be reduced to the metal. So for something of X plus charge, you will require X electrons to be reduced to the metal. Alright, so the key to solving this problem is essentially to find the value of X. And how do we do that? So the question tells you that you have 16 grams of copper that's being deposited. Now, given the mass of copper, we can now find number of moles of copper, which is equals to mass over molar mass, and that will give us a value of 0.25 moles. Okay, so now that we have found number of moles of copper that's being formed, we can actually find number of moles of electrons that that was passed into the electrolytic cell. And how do we do that? Is by comparing mole ratio. Right, if you look at the half equation for copper, for each mole of copper, it actually requires 2 moles of electrons for it to form. So for 0.25 moles of copper, the number of moles of electrons needed would be 0.5 moles. So essentially it means that 0.5 moles of electrons has been passed into the electrolytic cell. And if we go back to the front part where I mentioned that the same amount of charge means that you have the same number of moles of electrons, it means that there was also 0.5 moles of electrons that went into the titanium electrolytic cell. Okay, so the next thing that we need to find is the number of moles of titanium. We are given 6 grams of titanium, and that would mean that the number of moles of titanium is 0.125 moles. Alright, essentially what this means is that I had 0.5 moles of electrons and that 0.5 moles of electrons actually form only 0.125 moles of titanium. So the ratio is this, that for every mole of titanium, for each mole of titanium, you would require 4 moles of electrons to form. And that would mean that the value of X is actually 4. And that would also mean that the charge on titanium is 4+. So the answer is D.